So we want to go over section 2.2. Okay. So the limit as x approaches a is written limit as x goes to a of a function f of x will be equal to L. So write that down. The limit as x approaches a is so we'll draw a picture, but I just want to say that as x gets arbitrarily close to a, f of x gets arbitrarily close to L. Okay, so we have a graph here, f of x. This function will, let's see, 1, 2. I have a point 2 that's empty at 2, 3. So 1, 2, 3. There's a hole. Okay, but the function does continue down through the origin. And then I put a mark at 4. And then I had my function go through the point 4, negative 3. And then come back up. So we're going to come down. Last part of this function is to plot an output for 2 as 1. So the input 2 has an output 1 right there. Okay, we will look at the limit as x approaches 2. That's very obvious. Okay, does anyone want to type or say? Oh, lower the camera. What do you think this limit is? 3, yes, thank you. So you're going to 2 and your out, as your inputs go to 2, your outputs approach 3. And then we'll put a note. F of 2, the output for 2 is actually 1. Not the same as the limit, but that's okay. Okay, well, let's also do the limit as x goes to 4. Anyone give an answer? So it's also on the left side and on the right side. So your x values go to 4 on the left and right. Your outputs go to negative 3. Okay. One-sided limits. limit as x goes to a from the left will be written like this of f of x. So this says the limit as x approaches a from the left. Will equal L. Now we go on to the right where you have a plus sign as the power. Limit x approaches a from the right. Your function f of x equals okay, so just notes again that I'm just going to say we have x getting arbitrarily close to a from the left. As that happens, the outputs of your function are getting arbitrarily close to L. Here, as the x values, as inputs, get close to a from the right, your outputs get close to L, or the outputs of your function approach this value L. All right, new example. So I've got x-axis here. Okay, I have 5, and I also marked 4. At the point 5,4, it's empty. And my function just comes over like this. And then picks up again at the point 5,0, then goes up and over. Like that. Okay, we will find the limit as x approaches 5 from the left. Of this function f of x. So your x values are going to 5 from, let's see, this is the right side, left side, this way. As x values approach 5 this way, outputs approach 4. Yeah, thank you for the answer. Yeah, limit x goes to 5 from the right side. Inputs are coming this way, outputs are going to what? Anybody? Left side, you follow your function and you're going down, 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 down to 0. And then we'll kind of write this up as our next part of the notes. But if you were to approach 5, since the limits are not equal, the limit does not exist. So write that down. So as x goes to 5 from the left and the right of f of x, in this case, does not exist. Okay. So this is going to introduce the two-sided limit theorem. Two-sided. Okay. The limit as x goes to a. Oh, why it doesn't exist? Oh, that's this part here. But I'll say with the example that when like the right side limit doesn't match the left side limit, they're not equal to each other, then the limit from both sides doesn't exist. Again, the mathematical description will be the limit as x goes to a where f of x is equal to L if and only if and only if the limit as x goes to a from the right equals L, and as you go to a from the left is equal to L. So limit x goes to a from the right for your function f of x equals L, and limit x goes to a from the left for function f of x needs to match equal to L. So first part, L needs to exist. Next part, both sides have to match. And I have examples. Function. Okay, so let me say it again so I can erase everything. If you approach a from the left and you have a limit that exists, and it equals some number that matches the limit that you get as you approach from the left and from the right, that number exists and they're both the same, then the limit is equal to that number. All right, my function f of x is empty at the point 3, 6. So we're going to go over 3. 6. I have it go down through 2. And then at 5, -2. And then we're going to connect. We can swoop like this. And then at 5, 6, we're going to fill that in. Yeah, we can fill it in at 6. Then just have the function come over like this. So first, it is a function. Every input has an output where it passes the vertical line test. Actually, no, right here, we have a problem. We need to have this empty. Otherwise, that input 5 would have had 2 outputs, which is not a function. Now we want to find the limit of f of x as x approaches 3 from the right. Okay, so your inputs are going to 3 from the right-hand side, where your output's going. So if it's a closed circle on top, then it would. Just a side note too, it's okay if I had picked it like this. If 5, the output for 5 is -2, but then you can't have another output for 5. Only one, every input has only one output. So I could have had 5 go here or 5 go there, just not to 2 different places. Oh, in the previous example. Oh, I think I know what you mean. So let's work through this, and then I think I know what we're talking about here. So it doesn't have to be, the output doesn't have to actually be there. You're just really close to that value. So going to 3 from the right side, the limit is 6, even though there is no output for the function at 3. And limit as x goes to 3 from the left, f of x equals. So you're going to 3 from the left side. Your outputs are approaching 6. And it's okay that it's empty there. You don't need an actual output for 3. Just approach 3. Okay. So from the right you have 6, from the left you have 6. So the limit as you approach 3 from both sides equals 6. So I'm going to go through another example, but still bring up questions if I haven't explained, if I haven't given a clear answer. So we're going to try limit x is going to approach 5 from the left. Okay, 5, and you're on the left side. X is going towards 5, getting closer and closer to 5. Outputs get closer and closer to -2. We're going to try limit as x goes to 5 from the right. X goes to 5, right side. Okay, so you approach 5 from the right side for your inputs. Outputs are going to 6. So the limit from the right does not match the limit from the left. So the limit on both sides does not exist. Well, you know where base is, right? Limit x goes to 5 f of x. Okay, so I put a note and we'll write this down together. Okay. With limits, we are looking at behavior of a function around a point. Cool. All right, any questions? does that say? Okay. With limits, we're looking at behavior of a function around a point, which I could type, which is clear.
Professor, I have a question real quick.
Yeah.
Are these meetings being recorded?
Yes.
Okay, thank you. Just wondering. I didn't see that it was recorded. Okay, sorry.
Yeah, it's cool. And I try to post them as soon as I can. Yeah. Back to an example, I think. Actually, I have different cases. Oh, good question too. Recordings are going to be posted to the modules in Canvas. So these ones will be in the notes for week, or these notes are in the module for week 1. Okay, case 1. Where you have limit as x go to a of f of x. Limit as x approaches a of f of x equals f. Okay, so picked an example. You have f of x equals x squared. Parabola that goes through the point 1, 1. Okay, so I have the limit as x approaches 1 of f of x. So as you approach, as your x values get closer to 1 from the right side, outputs go to 1. As you go from the left side, x goes to 1 from the left, outputs go to 1. So your limit is 1. And f of 1 exists. It is equal to actually, I think I wrote this a little. We want to put limit of f of x as x goes to a equals a particular number f of a. So this is one situation that will happen. F of 1 equals 1. Also, the limit as x goes to a of f of x equals 1. Case 2. F of a does not exist. So for my example, the function is f of x equal to x squared minus 1 over x minus 1. Okay, so let's sketch this. And as we sketch it, we'll talk about the domain of your function. So we can't divide by we can't divide by 0. So the number down here for x cannot equal 1. So at x equals 1, we're going to have a hole where there's no value here. And then this will look like, let's see, x plus 1. So it's the line that goes through the point 0, 1. We're going to have a hole right here. Let me make sure I drew that. 1, this is 1, 2. Okay, so I just want to mention on the side that x equal to 1 cannot be in the domain of f. Because its output is f of 1. And if you put in 1 to that function, 1 squared, was it minus 1 over 1 minus 1, you get a number over 0. I mean, that number is 0, but the problem is dividing by 0. When that happens, this is undefined, or it does not exist. So the input x does not have an output f of x, so it can't be in the domain. That's just stuff on the side. Let's go back to limits. So I wrote that the limit as x goes to 1 does exist. So we can find the limit as x goes to 1 from the right. F of x goes to 2. As x goes to 1 from the left, f of x goes to 2. Even though we put f of 1 does not exist. So you can find the limit as x goes to 1, but not f of 1. Last case is case 3. Where the limit of f of x as x goes to a is not equal to f of a. So I have a piecewise function. It looks like f of x will be sine of x for x not equal to pi over 2. And we'll have f of x equal to -3 for x equal to pi over 2. We'll sketch a graph. All right, so the sine function, I know it goes through 0, 0, and you have one cycle that ends at 2 pi. And we're going to come through the origin at pi. There's a peak at pi over 2. And then you come down at 3 pi over 2. But at this number pi over 2, we're going to have a different output. So your sine function goes up but has a hole at pi over 2 comma 1. Through the origin at pi. Swoops. To -1. Goes back. And then continues. Continues to cycle on. And we also need to put in the output for pi over 2 is -3. So we're going to get the limit as x approaches pi over 2 of f of x. Okay, so you're approaching from the left side. X values go to pi over 2 from the left. F of x is going to 1. As x values go to pi over 2 from the right, outputs approach 1. So your limit equals 1. But f of pi over 2 is not equal to 1. It's equal to -3. So it's possible that the limit exists and is equal to the actual output of that point, or the limit doesn't exist, or your limit exists, but it just doesn't match the actual output at that point, which happened here. Okay, I think we want to talk about approaching positive and negative infinity. And that'll be it for today. Okay. First I have the limit as x goes to a of f of x equal to positive or negative infinity. It's going to be positive infinity or negative infinity. Okay, the limit as x approaches a no, wait. Rewrite this. Just erase. I'm sorry. Sorry to make you write stuff down. If you write it down, back it up. As x gets arbitrarily close to a. F of x grows without bound towards positive infinity. Or decreases without bound to negative infinity. And then I have some examples. So the first function, we have a sketch. There's a lot going on. Okay, let's do a vertical asymptote at 0 and 5. So the input 0 will not have any output for that function. Same for 5. 5 is not in the domain of this function. F of x will come over and then down. Let's put it in another color. So everything in the black ink will be this function f. It's also going to go like this, approach this asymptote, and come up and over, like that. And we'll have this side also like here, next to the asymptote, and then branch off. Cool. So let's get the limit as x approaches 0 from both sides. Anybody want to tell me the answer? Type it. Yeah, negative infinity. Thank you. Okay, limit. Okay, for your function, let's find the limit as x approaches 5 from the left. So from this side, your limit is what? Limit as x goes to 5 from the right. Approaching 5 from the right, we're going down to negative infinity. Which means that the limit as x approaches 5 equals
Would it not exist?
yes, does not exist. Thank you. Okay, I have another example, and then we'll call it good. Any questions? Okay. Starting fresh. So this function, same asymptote, similar picture actually. So we have a vertical asymptote here, 0. And then at 5, same thing. Then they had the function come down and over, down and over. And then this function's right here. Oh, I know. Sorry to make you erase, but I'm confusing the two graphs with each other. Okay, this picture, there's a part of your function in the second quadrant like this. Yeah. So right here is part of the function. This does stay. And then we have another piece here. Your function goes up, and then between 0 and 5, up and over. And then as you go on past 5, we're going to approach the horizontal asymptote. Limit. X approaches 0 from the left. That's the answer. Oh yeah, someone's already given me another answer. Someone wrote the limit as x goes to 5 from both sides for this function. You get out positive infinity. And you're going to 0 from the left, positive infinity. Let's do x goes to 0 from the right. Approach 0 from the right side, that's down to negative infinity. Wait, we need some space. Anything else? Oh, let's do the limit as you approach 0 from both sides. But does not exist. Yeah, thank you. Thank you for the answers, everyone. I think that's good for today. So we should be done with this section, and I will make homework for 2.2. And next week, we're going to jump to 2.4, and then we'll go into 2.3. And then the rest of the book will just go in order. So yeah, that's it for today. Thank you, everybody.